Okay, so as we talked about before, under the graph with the left hand endpoint puts us an underestimation of the area. Then we said if we did a right hand endpoint and we were above the graph, it was a little bit of an overestimation. So we're going to try to balance that out a bit and say, what if we chose a midpoint? So first of all, remember that our delta x is still 1/2. So first of all, if I start from 1 and I increment over to 1/2, that's going to be my first increment. So my first rectangle is going to be there. What's halfway in between that would be this area right here, right? Okay, so what I'm going to do is I'm going to start my rectangle there. So I'm going to come up approximately half on my function, and I'm going to go left and to the right with my rectangle. So it's a little bit over and a little bit under, so we should get a better approximation. Okay, so my next delta x is still 1/2. So if I want to get approximately in the middle of that, I'm going to roughly estimate myself up to approximately the middle as best as possible. So this is still a rough sketch. Now extend that to the left to meet your rectangle, and extend it to the right to meet your delta x. Okay, same thing here. My increment of delta x is 1/2 from this red dot to this red dot. I want to get as close as I can as possible to the middle of that and extend up to my function, and then sketch your rectangles to meet those values. Okay, now these are all rectangles of the same width if this was a perfect sketch, but I think you get the idea now. So my delta x is 1/2. I want to get about it in the middle of that as possible to sketch these rectangles. Okay, so the very first one we did left hand endpoint, the next one we did the right hand endpoint, and in this case our midpoints are in the middle, so that's the places we're going to evaluate x at right here, which is going to be different values, so we'll have to figure those out as we go. So let's put our formula down and then we'll plug in the information we need to solve. Okay, area of a midpoint polygon. Sum, our rectangles are still 4. F of W is okay, just to denote that it's not the same as the other two. One was a left hand, one was a right. This one's a midpoint. Delta x is still 1/2, so I'll pull 1/2 out front. Evaluate, our function is still x squared plus 1, so we pull our 1/2 out. And our very first term we evaluate, if this is 1 and this is 1.5, what's the middle of 1 and 1.5? 1.25, good. So it's 1.25 squared plus 1. This is our first term. Plus, well, this next point, if this is 1.5 and this is 2, what's the middle of that? 1.75. That's the second term. So then our third term is just going to be 2.25 in the same manner that we just calculated the other two. And our fourth term is going to be 2.75 squared plus 1. And so that's going to be our 4 terms, and we want to just plug that in and calculate. So I get my first one at 2.5625. And you can plug these in your calculators and check these results. 6.0625 and 8.5625. And when we add them all up and then multiply by 1/2, we get 1/2 times, it looks like 21.25, which is approximately 10.625 units square. Okay, so we can see we had 8.75, 12.75, and then this got us even closer because it accounts for the amount that was over, and the amount that's under kind of balances out, so this is very close.